Hello everyone. Today I'll be answering some advanced math section of the digital math SAT, and I chose the five hardest questions that uh, I'll be solving today. So please enjoy. So for the first question, for what value of x is a given expression equivalent to 70n to the power of 30x where n is greater than 1? So first, this equation might look a bit complicated, but it's actually not if you know how to switch from radical functions to exponential functions. So first of all, let's look at this part first. So 5 root of 70n is equal to 70n to the power of 1 over 5. And if we look at the others part, this would equal to 70n to the power of 1 over 6, and the whole thing is power of 2 again, and this is equal to 70n to the power of 1 over 3. So we multiply these two, so 70, I don't know why I keep writing n at the top, but 5 multiplied by 70n to the power of 1 over 3. And our exponential expression multiplication rule is that if we have the same base, we add the exponents. So 5 plus 1 over 3, which is equal to 70n to the power of 8 over 15. And the question says that this is same as this, so the 30x here is same thing as 8 over 15. So 30x is equal to 8 over 15. We divide both sides by 30 times 1 over 30. And this is equal to 8 over 450, which is same thing as 4 over 225. And that would be our final answer. So if you know how to switch from radical to exponential function, then you should be able to solve this question fairly easily. Next up, we got in the given quadratic function, a and c are constants. The graph of y equals fx and the xy plane is a parabola that opens upward. So opens upwards already tells us that a is greater than 0 and has a vertex at the point of h comma k. If k is less than 0 and f negative 9 is equal to f3, which of the following must be true? Okay, so from our information, we could set our fx to a x minus h squared plus k, since that is the vertex point. And this f negative 9 equals to f3, this tells us our vertex. So since all the quadratic functions are symmetrical like this, and if this is like the vertex, this might be negative 9, this might be 3, and this will have the same y value. So this is really important as the average of negative 9 and 3 would be the vertex. So the average of negative 9 and 3 is negative 3. And negative 9 and 3 is negative 3. So we get a vertex of negative 3. This is the x coordinate. So that is same thing as h. So h is equal to negative 3. So our fx equation could be rewritten by something like this. And if we expand this, we get ax squared minus 6ax plus 9a plus k. And we know that, oh, this is supposed to be all plus because since h is negative 3, the x, it has to be x plus 3 in order for x to be negative 3. My bad. So the question says the coefficient of the x value is 4, so we need to match these. So 6a is equal to 4, a is equal to 2 over 3. So we could again rewrite our fx as 2 over 3 x squared plus 4x plus 6 plus k. Since a is equal to 2 over 3, we know that this second option cannot make sense. And 6 plus k is equal to c overall here. So the option is c is less than 0, but k could be any value lower than 0. So k is a negative value, but k could be -1, -2, -3, up to like -100. And this would not guarantee that c is less than 0. C could be positive if k is equal to -1, for example. So this is also not always true, so the final answer is D. For the third question, the function g is defined by gf is equal to f of x plus 5. For what value of x does g of x reach its minimum? So they're a composite function, and the question is asking about the g of x's minimum. So first, since they are all related, we'll find the minimum of f of x first. So f of x could also be written as 4 x squared plus 16x plus, okay, this 262 is not divisible by 4, but it doesn't really matter in this case because we're finding the value of x and not the y value, like what is the minimum. So we could just leave this as blank, and you'll see why it doesn't matter in a few minutes. So if we take a square of this, it would be x plus 8 squared plus something, a different value from this, but it would be something looking like this. And we know that at x equals -8, fx is minimum. So for g of x, this is the same thing as plugging x plus 5 into x. So 4x plus 5, this is the x value, plus 8, and then squared plus something here. And if we rewrite this, this is 4x plus 13 squared plus something. So this is telling me that at x equals -13, g of x reaches minimum. So our final answer is -13a. Looking at our next question, minus x squared plus bx minus 676 equals 0. In the given equation, b is a positive integer. The equation has no real solutions. What is the greatest possible value of b? So first, I personally don't like dealing with negative coefficients in front of x squared, so I'll move all things to the right, everything to the right. So x squared minus bx plus 676 is equal to 0. And if we take the quadratic formula, we get b plus minus root b squared minus 4 times 676. And inside this root should be less than 0 in order to have no real solution, because you cannot have a negative value inside the root. So ultimately, b squared minus 4 times 676 has to be less than 0. And if we plug this into our calculator, 4 times 676, this gives us b squared minus b squared minus 2,740 is less than 0. So b squared is less than 2,704. And if we take the root of this, both sides, we get b is less than 52. So what is the greatest possible value of b? Well, b have to equal 51 in order to have no real solution. If we had b equals 52, that would mean that the inside root would be 0 and the equation will have only one solution. Okay, the final question. A landscaper is designing a rectangular garden. The length of the garden is to be 5 feet longer than the width. If the area of the garden will be 104 square feet, what will be the length in feet of the garden? So let's draw a diagram. This is the garden, this is the length, and this is the width. And the question says that the length is equal to width plus 5, as length is 5 feet longer than the width. And the area of this garden will be length times width, which is equal to w plus 5 times w, and this is equal to 104. So ultimately this is just a simple quadratic. So if we solve this, first expanding, w squared plus 5w equals 104, w squared plus 5w minus 104 equals 0. So we need to find two digits that add up to 5 and multiply to negative 104. And if you do it, you get that w plus 13 and w minus 8 is equal to 0. Yeah, this will take some time to do it, but if you list all the possibilities, this will be the only one that is available. You could also use calculator or quadratic formula if you want. So ultimately, w would have to equal 8 because w is always greater than 0. And the question is asking for the length and not the width, so you have to be careful. Length would be width plus 5, which is 8 plus 5, and that will equal to 13. So our final answer would be 13. So this was a quick solutions for the 5 advanced math questions. There were some algebra, some diagram questions, and I feel like this is like the hardest the SAT math could get. So if you know how to do all of these, then you should be fine. I hope you enjoyed this video, and comment in the comment section what video you guys want to see next, and if you have any questions, feel free to ask. Thank you.